Hi, welcome to our presentation. We're actually presenting on behalf of our coworker, Arade. I'm Drew, and this is my coworker, Julian, and we'll be presenting on file system test results analysis. So what we work on is a distributed file system. So it scales linearly. As you add nodes, you can get more storage space, more compute space. So with that, I'll pass it over.
Well, thank you, Drew. Can you hear me? Yeah, all right. So as Drew mentioned, we work on a scale-out file system, which can go from a couple nodes to tens of thousands of nodes. And besides that, besides being able to manage a system through the normal POSIX semantics, there are other input methods that like SMB, NFS, object that can be introduced into the file system. So this makes a very common scenario, especially for development on big corporations and projects like this, where the development of these kind of file systems is distributed among multiple countries. For example, in our case, it's among 4 continents. And one of the characteristics of having this kind of scenario is that we have check-ins like 24/7, right? But the teams that are dedicated to the quality assurance or infrastructure are normally collocated in one single place, which makes it very difficult for those teams to allocate their services to, provide help to all these teams that are very distributed. Also, we have some hectic release dates, as most companies. We have like 3 streams, different streams going on all the time, which is kind of a 2-week delivery and major releases every 6 months. And if we add to that we have to support different chip architectures like Intel x86 or power systems or mainframes, and also with different operating systems like Linux and Windows and the different distros, Ubuntu, SLES, all of that. And also that SMEs are collocated into so many different areas that it makes the development process and the development pipeline quite complicated. So to end up with this complicated scenario, we ended up with thousands or probably tens of thousands of verification scripts. I mean, when a project is starting, it becomes quite natural to start adding test automation. But once the project is getting bigger, and for example, in this case, a project that has probably 20 years, you can imagine all the kind of test automation that is going around all the places, right? And well, every team, we have, as I mentioned, different functionality, like SMB experts are in some place, for example, in Germany, and NFS experts are in another place. So that makes that there's a lack of knowledge on the people that is dedicated to provide the quality assurance services, because the inner details of that functionality really come from the subject matter experts on each of those areas. So that lack of knowledge can result in duplicate analysis, where different teams are trying to run the same kind of scenarios, which is time wasted, and also to duplicated defects. That is also a development cost, because probably the root case analysis goes through different development streams at some points to end up with a single root case scenario. And as I mentioned, probably at the beginning, one single person can manage all this QA assurance. But as suites start to grow up, then a single person is not possible to maintain infrastructure or QA test suites. And as implication is that the overall value of the test automation is seen as decreased, especially now that we are being forced to become more agile, and test automation is like the way to become more agile. We face this reality that when we have all this complexity in products like file systems, test automation starts to lose its value. And also the number of false positives increase, which means that the quality reports that we are providing are not really a clear indicator of the quality of the overall product as it is. And now instead of the human effort going to manually testing stuff, the human effort goes to clarify the status of, oh no, yeah, this wasn't supposed to fail like this and stuff like that, which is, counterproductive and not really a good ally of going agile. And the test teams start to grow and grow. And this is like an avalanche, right? Where test team starts to grow, so all this complexity with more people start to grow as well, because those test teams need to be in sync and very coordinated and need to be experts on many of these areas, but that is not the case realistically. So that is the intention of this test analyzer that we have been developing and running in this scale-out file system, and is to have a continuous integration focus framework that can help us to ease that process and analyze the results and provide verdicts and also decrease the human intervention that is needed, and also the false positives and duplicate defects that we are getting through the development cycle. For this framework, we are using the leading edge tools or the leading tools in continuous integration like Gerrit, Jenkins, and Robot. So this demo is focused on Robot, but it doesn't mean that this approach is generic enough and can be applied to any other kind of framework or programming language.
And is that anybody here familiar with Robot? No? Everyone? But it's basically an open source test-driven development framework. It's written in Python, Java, or .NET, depending on your use case. But it's basically meant to be very human-readable, self-documenting. It logs everything very well, so you get a ton of benefits with just even wrapping your existing test cases, whether they're binaries or scripts, in Robot.
Yeah, and thanks, Drew. And just a brief introduction of what we do into our pipeline, and it's very common in the development process. We have check-ins by the developers, which are picked by Gerrit. So that Gerrit Jenkins triggers some part of verifications that can go from, okay, this new check-in builds and the file system can be compiled, up to having more system-level tests that can go to thousands of tests that go running for days, hours or days. And when we start, opening defects and trying to debug stuff, there are four main things that we always end up following into these four questions. First one is what? What's the culprit of this failure? And also, what step did it fail in? So we need that granularity of, okay, this thing failed when we tried to do a log of some file in some byte range or things like that. So going to that granularity is needed to know what happened. Also, when it happened, is this the first time that we see it? When was the last time that we see that scenario complete? And also, that provides us insights on what version of the code we are running, especially if we are developing separate branches and streams. Another important thing is where it happened. In distributed file systems, that is normally a cluster, but as I mentioned, we can have clusters from 2 nodes to thousands of nodes, so that is important. And also having the node granularity of, okay, is this failing just on a single node, or it is failing on a group of nodes that share certain characteristics? And also, it is if it is recreatable, if we see those kind of failures in just that environment, or we are seeing it on a broader range of environments. And finally, how did it happen? For example, what installation type it had, and how often are we seeing this? Is it something that is happening randomly, or is this really a functional problem that every time we are hitting those kind of problems?
And so basically what we started developing then is this tool called Test Analyzer. We tried to make it very simple, so there's really only 3 commands to run. First one is the init, so that just creates the database that we use in all the tables and creates all the schemas. And then we have the run, which essentially encapsulates robot, like a robot run. It does the test execution, the data extraction, the rule validation, and then we'll decide if it should, say, open a defect or notify someone of the issue. And then this post function, which is the thing that actually then sends, creates a defect or emails someone to let them know that their test failed, so they need to fix it before it'll get merged. Or if it's a system level test, then it'll open the defect on behalf of someone. So I guess many of you aren't familiar with robots. So we basically, you can incorporate a bunch of robot tests into a suite. Each of those can have tags that you can choose to run stuff. So for instance, if we run SMB bucket, it'll just choose all the tests that have the SMB tag, and then you can get a grouping of tests. So each of those will have preconditions like setup, cleaning up various things, or configuring something specific to the test. It'll run the test itself and then do a cleanup. So once all those tests run, then our test analysis tool comes into play. So here's the schema that we currently use. We built it with SQL Alchemy, which enables us to, right now we have SQLite 3, but with SQL Alchemy, it lets you interchange different databases easily, and it can build a new database on, say, like MySQL, just switching a couple parameters. So it's a little small, but this is still changing, so what you see here will be a little bit different than what we show in the demo. But it basically just keeps all the information, like various servers that we use, the architectures of tests, of the servers, of the environments, as well as the status of test cases, like the start time, the end time, everything that Julian mentioned from the previous slides. So real quick, I'll just show you a quick demo, just starting the database and running a quick robot test. Okay, is that big enough for everybody? Okay. So first, if we run the init, like I said, this just creates the database. It creates some Python file that has all the functions to add stuff to the database, like the test cases and all the tables that we need. So just taking a quick look at the database. There's the tables that we created. And then if we look at the schema, pretty standard. But like I said, this is probably different than what you saw even on the previous slide there. Just know that it's continuously changing. So now I'm just going to do a quick run just to show you what gets populated in the database. So this right Right there is the test analyzer run. Everything after that is actually all robot. So it's literally substituting how you'd call robot with our version, then we call robot on behalf of that. So these are very specific to our case. But if you do look at robot, you'll see that these are all pretty standard, just injecting runtime variables and things that we need for our runs. So for this case, we're just doing a quick TDB verification, just making sure all the databases for Samba are in the right spot that we expect. You can see it runs pretty quick, so this is usually like a unit test that we run, or I guess a functional test that we run once we install a new version of Samba. So here, all the tests passed, and then at the very bottom, you can see that the test analyzer completed successfully, which means then that we populated some stuff in the database. So in this case, we ran SMB TDB on a specific version, which is 5.02. It's in the Samba bucket. And then, sorry, if I turn headers on and then rerun that, you can see that the is stable is set to 0, which Julian will get to in the next slide. I'll let you change it.
Okay, so executing this repeatedly and over the years, we also come out to some common behavior that we'd want to enforce. And it's quite standard on test validation. So the first filter that we go through is the return code. If an application is, well, not dual, but is consistently designed and developed, then return code should correspond to certain kind of failures. So that is our first indicator of what kind of issue we may be dealing with. But applications are not perfect, so we go through more filters to know if we are dealing with similar failure conditions or not. The next one is the test case step. Like in the demo that Drew just did, we had like 4 or 5 steps in the test case. So that is another indicator for us to know exactly in which test case it failed, and even more granularly, beside that high-level view, in which keyword it failed. So if we have a same return code and we have a failure in that same, let's say, keyword, we are more confident that we are dealing with the same kind of issue that we may have seen before. Or we may be more confident to know, okay, this is a new issue and we need to raise a defect for that. And then the last filter that we go through is signature validation. That is actually the return code, the return the output that comes out from the failure itself. We cannot match just, okay, this output of this environment with this other output of this environment and saying, okay, yes, these are the same kind of problems. We need to do some kind of filtering because different executions in time may provide different kind of value, starting by very, logical ones like the date. If there are dates in there, then signatures are not going to match. So we ignore dates, right? Another one is system information. If the system information is being logged and we are running on different environments, then also signatures are not going to match. Then we ignore that. Other can be, for example, process IDs, that process IDs numbers are being logged from different environments with different numbers, of course, so that also needs to be ignored. But what we aim to do is to do this the most generic as possible. So being able to establish regular expressions, so each product or each file system or storage product that is running this kind of validations can add or remove regular expressions to make sure that the error signatures match or not, and get to know if we are dealing with known defects or with new bugs. Another of the rules that we have established is knowing when a test suite is stable. Even in the development of test suites, we pass through certain workflow where at the beginning the test suites may not be very stable and may be failing for things that are intrinsic to themselves that were not well thought and are giving some failures, but they are not actual bugs of the product, but bugs in the test suite by itself. So we have established this rule that is not something that we have or are thinking as hard coding, but what we are saying now is that if a test suite has already passed on 3 different versions of the builds, in that we have had 3 iterations and the suites have been passing, we mark that as stable. And that number can change, or it's intended to change depending on the product that is using this. But for us, if 3 different executions with 3 different builds have passed, and that can mean that they have been run on very different environments, probably with different CPU architectures and underlying storage, then we mark those as passed. So when we see a failure in those stable test suites, we are confident of saying, okay, this is not a test suite failure, but it's a product failure, and we raise a defect automatically, which is something we are going to see now.
Okay, so like Julian mentioned, we go through the various validation steps. If it runs 3 times, we mark it as stable, which is user configurable. So now I'm just going to run that same test just 2 more times, just to show you that we do in fact mark it as stable. And then so each of these times, so it's running it twice. Each time it'll populate various tables with additional information. So it'll see that it's the same release in this case, the same test case. So it'll start incrementing stuff, just starting the count of how many times it's run on a specific release. So here you can see that the analyzer completed again. And then in a minute here, we'll inject a failure and show what happens with that. Okay. So here now you can see we ran it 3 times in a row. They were all successful, so we marked it as stable. So now if we inject an error, so basically if we just cause the failure, I mean obviously in a real example this would Okay, so there we have our failure. Now it's running the analysis again. And here you can see that we opened a defect. So this is a defect specific to us, but we're planning on adding like plugin functionality so you can open a defect to whatever tool you use, like Bugzilla or any number of defect trackers. So if we look at this real quick. Yep.
Is the framework cognizant of sort of change history? Is it able to figure out that you just changed the test case, so it's likely a test bug rather than a code defect?
Yeah, I'll get to that in a second here. So here, this is our defect tracker. So you can see right off the bat that an automated tool ran it. So Test Analyzer opened the defect. It was a robot test. Here's the test case name. And then this is the signature. So you can see tempfs does not equal tempfs1, because that's where we expected the TDB to exist. Oh, sorry.
Oh, sorry, just a quick comment that also all the environment information is posted in there. That is also not meant to be hard-coded. But for every kind of product to put in there the information needed to start debugging from the development side. So there we can see all the steps that happen in which kind of environment, that well, a lot of information that is relevant to us as a file system, but that becomes very useful when we start debugging some issues.
So yeah, you can run your own scripts to gather all the data you need at the time that the failure happens to populate like the defect. And
is it done automatically or you need to stop it?
It's automatic. So this was all dynamically generated.
If a test case fails, does it clean up or?
That's configurable via robot. You can say on failure, continue with the cleanup, continue with all the tests if you want, or exit out immediately with non-zero return code, or exit out immediately with some non-zero return code. So yeah, that's robot-specific stuff.
So every test case requires a separate setup or to set up once and run a batch of?
Yeah, in our case, yes, every test case has a setup, a precondition, then setups, then runs whatever it wants to validate. Then it has a post condition where it clean ups and leaves the environment in a clean state, so the next one can pick up on a clean environment and don't present problems because of the previous set that was executed.
And that's really the approach that we took, although not everyone takes that approach, but we expect the system to be configured, clean, healthy before we start the tests. So if like a test case changes some parameter, then it is expected to also change it back at the end. So I'm just going to run the test one more time just to show what happens when you have an existing defect and it knows that it opened one, but you still get the same error. You probably don't want to open a new defect and have just a bunch of duplicate defects, especially if you're running this stuff multiple times a day or, yeah.
That can also represent different people in different locations running the same kind of scenarios, and where we get into duplicated defects and also duplicated efforts from development to root cause and debug, especially if they go different paths at the beginning and they end up converging at the end, which is wasted development time. So it's one of the things that we want to attack here as well.
And so here from the output, you can see that the same defect was modified. Above it was created. So if we go back in there and refresh, you can see that a new comment was added to the same defect. It gathered the same information since we were running on the same system, but it has all the cluster information. So you could even start getting a count of how prevalent this issue is if it's hitting multiple ARCs or OSs or just one specific cluster, many specific clusters. So that should also help with debugging. And I guess for those of you that aren't familiar, this is robot here. So it's broken down into keywords. So one benefit that we found is that if you write good enough keywords, then even non-developers can run things because it's very human readable. Developers can write specific keywords, and then as a tester that may not know how to program exactly can just do the equivalent thing that they would be doing manually on the command line. They could say, oh, cd to this directory, run this command, expect this output, and if that's all good, then it works. So you can abstract enough stuff with robot keywords that it makes sense for non-developers to also create automated tests. Okay, so here I fixed the issue. TempFS is now back to its expected location. So I'm just gonna, sorry, bear with me. I'm gonna run it 3 more times. And then sorry, I forget who. Someone had the comment on the commit and to see if the file may be changed and it's a test case issue and not an actual defect. We provide the commit number. So right now this is just a fake commit. But basically it also does check that to see if from the last time the test case passed to this time, if it looks at the diff of the commit, sees if the file changed, and then potentially just doesn't open the defect and instead like emails whoever edited it last or the owner of the test script.
And that can be any kind of identifier, but for example, for us it is a Git hash, right? If this is the latest Git hash of the test script where it passed, if that changes, then yeah, we will alert, hey, this execution failed, but by the way, also the test script failed. So give it a check before we open a defect for you.
Okay, so lastly, we ran it 3 more times. That test case is now deemed as stable. So if we just make one last change, and cause another failure. So there, sorry, I maybe moved a little quick. I changed TempFS to be expected to be in TempFS 2, causing a little bit different but unique error. So even though that the signature is relatively the same, this is going to cause a new defect to be opened because it is different. But yeah, I don't know if that'll be configurable, if it, like how different issue can be. If it's just like 1% different, then maybe it's probably the same thing, or if it's more than 10% different, then open a new defect, or we don't know.
Yeah, in this case, any difference in all those 3 filters that we went through will originate a new defect. We are assuming that, okay, if any of those are different to something that we already have reported, then it is a new one. But yeah, as Drew mentioned, we are still developing this, and probably we could add some feature of, a threshold or some branch of, if it's 90% the same, then just attach the information to the already open defect.
And so here, so since we had a different signature, it created a new defect. And then, so just really quick to show you guys the signatures table. So here you can see we have the 4 runs. I guess more than 4 runs. For the various failures that we injected, it added the signature to each one. So this So you can see the test case ID, the test suite ID, it's all tracked in there. And then because like in this case, TempFS1 is from test case 3, test suite ID 1. And then the next one was from test case 4 because we had 2 failures in that test case. So it's unique signatures that's tracked across all the test suites and the test cases. And this signature table right now is the parsed info after all the regex expressions get run. That's what we store in there. We don't store the non-parsed output.
Yeah, and I mean those are very straightforward failures, right? But the signatures can be pretty long and have a lot more of information in there. But this is kind of pretty visual and easy to go through right now, like in a demo.
I think I missed it.
Quick question. So when you're developing a new test, will you not autofile defects until it's been marked as stable in your database or whatever?
Yep.
Yeah.
Yeah, it won't be populated in the database at all. So then it needs the 3 good runs before it's marked as stable.
Yeah, and it also gives test case developers like a chance to get it right, because we may be merging stuff, thinking, okay, this is ready for production, but we always miss things. So yeah, and that rule of the 3 executions is arbitrary. It's our our product, but that can be changed depending to other storage products that may be using this.
And in your actual environment, do you have just a single database that's kind of global for your entire environment as opposed to each test client maintaining its own database, or what is that?
Yeah.
Yeah, so this will hook into our main Jenkins pipeline. So although, if people run this stuff individually, we probably won't track it. But in our actual main production pipeline, all versions, all tests will go into the same database.
Yeah, and we are showing now like the inner working of that, but the idea is that you put it in Jenkins and you don't need to know about it anymore. I mean, developers or testers do not need to go through the databases and do things like that. They just submit their storage testing scripts. It goes into these buckets, into ideally a continuous integration pipeline cycle. And if something kicks out that we haven't seen before, then a defect is open. So that attacks a lot of these complexities of having big teams analyzing thousands of the suites and opening defects and creating a lot of chaos. That is what we see and what we do also. And really streamline that analysis process into a very transparent process where you just need to care for developing your new functionality and developing the unit test case or system test cases that are going to test that. And then that test process is taken care of, which in our view is pretty cool. So as a summary, this test analysis becomes pretty demanding and pretty complex, especially when we are talking about file system or storage systems that have a lot of components in there. So a framework to provide this kind of verdicts and testing help becomes very usable and very valuable as it is. And also that rules need to be defined, and those rules can be adapted according to different products that are using it. We believe that all this schema is very standard, so at least any kind of storage product can implement a similar schema where there are environments, there are signatures, there are the cases, the suites, stuff like that. But that doesn't mean that it cannot be grown by different products. Like, okay, I need this kind of table to to depict my environment or this kind of thing. So we also intend to make it flexible to be, as well as regular expressions added, also to add another kind of correlations between members of the database. And well, we are in the process of open sourcing this. Not ready yet. It's kind of a long process. But if you are interested, our contact emails are at the beginning of the presentation. And keep a look at GitHub/IBM. So that's where it's going to be, we hope, soon posted. And well, I think that's what we had planned to show now. So if you have any kind of questions, yeah?
I thought it will modify existing defects. Will it reopen?
That's something that we are still debating. If a defect is already closed, if we want to reopen it and just keep all the historic in there, or open a new one. That's something that we have not really decided yet. But okay, well, if nothing else, thank you very much. If you're interested, please feel free to contact us. We'll be happy to be in touch.